Alright, so today we'll be talking about, in part 2 of the volumes, arcs, lengths, and surfaces series, we'll be talking about slicing by parallel planes and then the washer method. But first off, let's go with the washer method. Okay, washer method is very closely related to the disk method in that we'll be dealing with a shape which we rotate about an axis, but we will be cutting out a portion inside, so it's almost like we're funneling out. If you've ever seen a machine lathe, we're actually calculating the volume of it just by knowing the equation of the stuff inside. Okay, so let's actually go to Desmos and see a graph of result of what we want to actually have done. Alright, so if we zoom in a little bit and ignore the bottom part, now, ignore the fact that I have just done a bunch of less thans up here in my restrictions, okay? Let's actually look at the shape enclosed, and let's make this a little bit darker of a color. I just can't see it as well. Okay, let's make this the shape enclosed by this curve right here, okay? Alright, so now as we're actually looking at this, let's take a look at the actual rotation. Okay, so y equals negative 2x squared. Okay, and let's make that 0 less than x, which is less than 0.5. There we go. Okay. Alright, so if we take a look at it, we're actually spinning this around the x-axis, and we're going to have it in terms of y. Okay, so technically I should rewrite this whole top part as y equals the square root of x divided by 2. Nope, it has to be inside, so let's divide that by 2. There we go. Okay, there we go. Now we have it all set up. Okay. Alright, so as we take a look at this, we're going to actually be working with it this way. Alright, so here is the upper part and here's the lower part. So like with the disk method, I'm still going to rotate this about, so it's going to be rotating about this origin. So if you can imagine this going into the Desmos and then coming out and then in and out, I'd be making kind of like a washer type method. In other words, I'm using my lathe to go into the actual object and to grind it down so that all I'm left with is this really cool like parabolic type shape. Okay, now here's the cool thing is that I actually have my limits or my beginning and ends. Okay, alright. So let's, you know what, let's replicate this bad boy. Duplicate, there we go. Except we'll make it negative. Ah, there we go. Now we have our nice picture again, and let's make this black. Okay, so here's what it is actually going to start looking like, okay? Alright, so I'm going to be rotating around in this fashion. Now the cool thing is that this is very close to the disk method in that I take this top part. This is the outer radius, or the bigger radius. It's just the taller because it's, you know, further away from x, and I'm going to subtract this. Okay, and as I do that, I'm going to actually find the area of this shape. Okay, now the dx is going to be the actual disc that, or the actual washer that I'm going to cut out of this section. And remember, washer is going to be a hollowed out disc type effect. Right, so when I go into it, this is still going to be pi right there. But then I'm also going to have that first radius. Now if you notice, the square root one was the bigger one, so I'm going to have the square root of x, and I'm going to square that. Let's add another set of parentheses. And I'm going minus the x to the second squared, and I'm going to square that. Because remember, this is dealing with our radiuses, and our radiuses definitely have to be squared. Okay, so it's almost like I factored out that. Okay, alright, now here's the cool part. You're probably already licking your lips going, oh my gosh, these two are going to cancel out. Oops, do you know what I forgot to do? I definitely forgot to put in my 2's. So this was going to be 2 right here. Oops. It's going to be 2 right here, and this would be divide by 2. Okay, let's get that in there. Haha, now I got it a lot better. Alright, so what this is going to look like is this is going to be pi times x over 2. Okay, that's going to be in its original set of parentheses. Okay, because when I square it, it's just going to get rid of that square root. And then the other one is going to be minus 4x to the 4th. Okay. All right, and that's some pretty easy stuff to just work with it, because now I'm going to just integrate this. And remember, I'm going up from 0.5 from 0. Okay. All right, so I start plugging everything in. I'm going to have, once again, pi in the front. Okay, now I integrate this, and this should be x squared divided by 4. Okay. Once again, I got to put that parentheses there. If you keep your parentheses, it really helps keep track of your thoughts and everything. And then this one's going to be minus 4/5 times x to the 5th. And we are going to integrate from 0.5 to from 0. Okay? All right, so we plug in everything. Now, if you notice, I'm not going to need to subtract anything because it's definitely going to be 0 right there. So this is just going to be pi times, let me see, if I plug in 0.5, that's going to become 1/4. 1/4 divided by 4 is going to be the same as 1/16. Okay. Oh boy, that is just going to be an ugly number. I'm going to have to get a decimal approximation for the next one. So this is going to be 4/5 times 1/2 to the 5th power. Well, no, that's actually 30 seconds. Okay, and that's going to be minus 1/40th. Yeah, because this is going to turn into 4/5 times 1/32. Yep, that's right. Okay. All right. And as you can see, you can just continue to work on this. This one will be from, that's already taken care of. So as you simplify this one, you're probably going to get a decimal approximation of this, right, which is just working down to 0.11781. Okay. All right. Now slicing by parallel planes, just once again, you are just cutting into the pieces. You're actually making the disc or the actual washer as you work along. So remember, slicing by parallel planes, still the same area times the dx, which will give you the actual shape of it. Okay. All right. That's it for part 2. I'll talk to you later. Bye.